The universe is a vast and mysterious place, filled with countless wonders and secrets waiting to be discovered. From the tiniest particles to the largest galaxies, everything in the universe is governed by the laws of chemistry. The periodic table is the key to understanding the chemistry of the universe. It contains all the elements that make up everything we see around us, from the air we breathe to the stars in the sky. In this video, we will explore the chemistry of the universe, from the birth of stars to the formation of planets and the origins of life itself. We will see how the elements that make up the universe are created, how they are distributed throughout space, and how they come together to form the building blocks of life. So sit back, relax, and prepare to be amazed by the incredible chemistry of the universe. Stars are born in vast clouds of gas and dust called nebulae. These clouds are made up of hydrogen, helium, and other elements. As the gas and dust in the nebula begin to collapse under their own gravity, they heat up and form a protostar. In the core of the protostar, nuclear fusion reactions begin to occur, fusing hydrogen atoms together to form helium and releasing vast amounts of energy. Once the protostar reaches a certain size and temperature, it becomes a main sequence star, like our own sun. When a star runs out of fuel, it can explode in a supernova, releasing even more elements into space. In some cases, the core of the star collapses into a neutron star, a dense object made up of tightly packed neutrons. And in the most extreme cases, the core can collapse into a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. The elements created in stars are then distributed throughout the galaxy, where they can come together to form new stars, planets, and even life. Planets form from the same cloud of gas and dust that gave birth to the star they orbit. As the protostar begins to heat up, it creates a protoplanetary disk, a flat disk of gas and dust that surrounds the star. Within the disk, small particles called planetesimals begin to stick together, forming larger and larger objects. Eventually, these objects become large enough to become planets, like the ones in our own solar system. Some of the planetesimals that didn't form into planets become asteroids, which can be found in the asteroid belt between Mars and Jupiter. Others become comets, which originate from the outer reaches of the solar system and can be seen as they pass close to the Sun. Some planets also have moons, which form from the same material that formed the planet itself. Gas giants like Jupiter and Saturn form further from the star, where the protoplanetary disk is cooler and there is more gas available to form large planets. And beyond our own solar system, astronomers have discovered thousands of exoplanets, planets orbiting other stars in the galaxy. Some of these exoplanets are even in the habitable zone, where conditions may be ripe for liquid water and the possibility of life. Life on Earth is believed to have originated in the oceans, where the conditions were just right for the formation of the first living organisms. The first living organisms were likely single-celled organisms, which evolved over billions of years into the complex life forms we see today. The key to the evolution of life is DNA, the molecule that contains the genetic information that is passed down from generation to generation. RNA, a related molecule, may have played a role in the early evolution of life, before DNA became the dominant genetic material. Scientists have also conducted experiments to try to recreate the conditions that may have existed on early Earth, such as the famous Miller-Urey experiment, which produced amino acids, the building blocks of proteins. Life on Earth has also been found in some of the most extreme environments, such as deep-sea hydrothermal vents and acidic hot springs, suggesting that life may be able to survive in a wide range of conditions. Beyond our own planet, astronomers are searching for signs of life on exoplanets, looking for the chemical signatures of life in their atmospheres. The Drake equation, a mathematical formula used to estimate the number of intelligent civilizations in the galaxy, suggests that we may not be alone in the universe. The chemistry of the universe has given rise to the incredible diversity of life we see on Earth, and may hold the key to the discovery of life elsewhere in the cosmos.